Ever wonder how it all began? How the universe, with its countless galaxies, stars, and planets came into existence? It's a question that has elicited fascination and curiosity for as long as humans have looked up at the night sky. But the enigma of our cosmic beginnings isn't entirely without answers. The Big Bang Theory, a phrase you've likely heard, offers some answers. Let's delve into what this theory is all about. The Big Bang Theory, it's not just a popular TV show, but a scientific explanation of how the universe began. Let's journey back in time, about 13.8 billion years ago. We can't imagine a universe filled with galaxies, stars, or even atoms at this point. Instead, picture a state of extreme density and temperature, a point of singularity. This infinitesimally small, infinitely hot, and infinitely dense point contained what would become the universe we know today. Now let's press the cosmic play button. In a fraction of a second, this singularity began to expand rapidly in a hot fireball of energy, marking the beginning of time and space. This event, this Big Bang, is not an explosion in space as the name might suggest, but an explosion of space. The universe itself was and is still expanding. As the universe expanded, it began to cool. After a few minutes, it cooled enough for protons and neutrons to come together to form the first atoms, primarily hydrogen and helium, the lightest and simplest elements. This period is known as nucleosynthesis. But the universe was not yet the star-studded expanse we see when we look up at the night sky. It was a hot, dense soup of particles, a cosmic fog. It took around 380,000 years for the universe to cool enough for these atoms to capture electrons, creating neutral atoms and clearing the fog. This is when photons or light particles could finally travel freely across the universe. Over hundreds of millions of years, these atoms, under the force of gravity, clumped together to form stars and galaxies. Stars ignited, creating heavier elements in their cores, and upon their death, scattered these elements across the universe. These elements eventually came together to form new stars, planets, and eventually, life. So, in a nutshell, the Big Bang Theory explains the journey from a hot, dense point to the vast, complex universe we see today. You might have some misconceptions about the Big Bang Theory. It's time to set the record straight. Let's begin with one of the most common misconceptions, the idea that the Big Bang was a massive explosion. This image of a colossal fireball erupting from nothingness is dramatic, but it's not quite accurate. The Big Bang wasn't an explosion in the traditional sense. Instead, it was a rapid expansion of space itself. Picture a balloon inflating. As it expands, every point on its surface moves away from every other point. That's a bit like how the Big Bang worked. Another misconception is that the Big Bang Theory explains the origin of life. While it does describe the development of the universe from the first fractions of a second up to today, it doesn't delve into how life began. That's a separate field of study called abiogenesis. The Big Bang Theory and the origin of life are two distinct concepts, each with its own set of scientific inquiries and theories. Then, there's the idea that the Big Bang happened at a specific location in space, like a bomb going off at a particular spot. But remember, the Big Bang was an expansion of space itself, not an explosion within it. It happened everywhere at once. The universe doesn't have a center point where the Big Bang occurred. Lastly, some people believe that the Big Bang Theory is just a theory, implying it's just a guess or a hunch. But in science, a theory is a well-substantiated explanation of some aspect of the natural world, based on a body of facts that have been repeatedly confirmed through observation and experiment. The Big Bang Theory is supported by a wealth of evidence, from the cosmic microwave background to the large-scale structure of the universe. Understanding the Big Bang Theory means setting aside these misconceptions and looking at the evidence we have. But where is the evidence for the Big Bang Theory, you might ask? Well, it's not as elusive as you might think. There are two main pieces of evidence that astrophysicists lean on to support the Big Bang Theory. The first is the redshift of galaxies. When light or other electromagnetic waves from an object are stretched out, they appear more red, a phenomenon known as redshift. This happens because the universe is expanding, and most galaxies are moving away from us. The farther the galaxy, the faster it is receding, and the more its light is redshifted. This observation is in perfect alignment with the Big Bang Theory, which proposes that the universe started from a single point and has been expanding ever since. The second piece of evidence is the cosmic microwave background radiation. This is the afterglow of the Big Bang, a sort of echo from the early universe. Discovered by accident in the mid-20th century, this radiation permeates all of space. It's remarkably uniform, yet it has tiny temperature fluctuations. Those variations give us invaluable insights into the universe's infancy and the conditions that gave rise to galaxies and large-scale structures. To sum it up, the redshift of galaxies and the cosmic microwave background radiation provide compelling evidence for the Big Bang. They paint a picture of a universe that started incredibly hot and dense, and has been cooling and expanding ever since. These pieces of evidence strongly support the Big Bang theory, making it the most accepted explanation of the universe's origins. The Big Bang theory is more than just a theory. It is a scientific explanation backed by a multitude of evidence. It's the foundation of our understanding of the cosmos, the grand stage upon which the drama of existence plays out. It offers us a window into the past, a glimpse of the first moments of creation. Throughout our journey today, we have unraveled the intricacies of the Big Bang theory, debunked common misconceptions, and dived into the compelling evidence that supports it. From cosmic microwave background radiation to the vast cosmic web of galaxies, the fingerprints of the Big Bang are imprinted all around us. This understanding is not just academic. It shapes how we perceive our place in the cosmos, our relationship with the universe, and our understanding of the fundamental laws that govern reality. So the next time you look up at the night sky, remember, you're not just seeing stars, you're glimpsing into the origins of the universe itself.